Hey, everybody, welcome to tonight's edition of the Triangle Area SQL Server User Group's Business Intelligence and Data Science meeting. Before I do go live, or go live with this presentation, I do want to talk about SQL Saturday Raleigh, which is coming up on May 17th. I'm going to drop a link to that in chat in case you have not signed up. This is a free one-day training. It'll be in Durham this year, so come check it out. Everything is free unless you pay for lunch, in which case, it's not free, but it's still worth the lunch money. And we're going to have a full day of great sessions. The schedule's already out there. Everything's set up. Go sign up. See you on May 17th. And if you want to, even, Brent Ozar is going to give a pre-con for the group on May 16th. Now, that one's not free. You will have to sign up for that and pay actual money. And as a result, I do have links for that on the SQL Saturday website. Go check that out and sign up. In the meantime, let's talk about DuckDB. So I need to shrink myself just a little bit so that it's easier for me to show the entirety of my slides. But welcome. My name is Kevin Feasel. In case you're not familiar with my game, I am a data scientist by day. I do a little bit of consulting. I'm also a Microsoft Data Platform MVP and also an ML MVP. I keep forgetting that. I'm out of Raleigh, North Carolina, and I've got a blog called Curated SQL, where each day I try to find and link to 5 to 10 interesting posts on topics all across the data platform space. So it's curatedsql.com. What we are going to do tonight is talk about this product known as DuckDB. We're going to get an idea of what it is, how it fits in a world with so many other data platform products, and then we'll try it out. I'm going to show you how to work with some data sets. We'll talk a bit about administration, maybe a little bit of product tuning, performance tuning, talk about some product limitations. Tech Renaissance man. I appreciate that. Thank you, Elaine. So what we'll do, we'll install it, obviously. I'm going to use the Python version of it tonight, just for simplicity's sake. We'll talk a bit more about the various versions and what that even means. But within that, we're going to have a notebook. We'll connect to a database and do some databasey things. We're going to see some of the features and capabilities that are in DuckDB that you won't find in many other data platform products, as well as many things that you will find in plenty of them. So we'll see how well this handles classic ANSI SQL. And finally, we'll talk a little bit about the bête noire of any programming language, and that is injection attacks. So we've got a lot to cover. It's going to be some fun. If you have questions, drop them in chat. I see them right in front of me, and then we can go forward. So let's talk about an overview of DuckDB. So DuckDB, this is a single-user open-source database. The purpose of it is analytical data processing. If you are familiar with SQLite, or even with SQL Server Compact Edition, the idea is this is an in-memory process database with, asterisk next to in-memory, because technically it doesn't have to be just in-memory. But basically, this is an in-process database that you can connect to and perform analytical operations. SQLite allows you to do classic relational database work, and it's fantastic for mobile applications and for basically any application where you really want to access data using SQL, but you don't want to have a customer stand up a relational database or an end user stand up a relational database. So, hey, you want to play my video game? Sure, but I'm going to have you install SQL Server first. Not usually a requirement that's going to fly very well. So that's where SQLite fits in, and DuckDB kind of in a similar space, but for analytics, for data scientists. So let's talk about why we might use DuckDB. The first one is it has a very low resource overhead. In order to run DuckDB, you don't need much in the way of processing power. You can run it on your laptop. And in fact, that's kind of the ethos of how we would run DuckDB is I may not have access to a big, fancy, powerful server, but I have data that I need to access and analyze and work with. So this is a quick and easy way of being able to write SQL queries against several types of data very easily. There is no dependency on network resources. In fact, I would say that's the beneficial side. Now, the other side of it is you cannot host DuckDB as a service that multiple people would access. So this is not like your SQL Server, your Postgres, your Oracle. This is not a data platform product that you're going to have a large number of clients connecting to. Instead, it is in process. Your application is accessing DuckDB resources in memory, kind of tied in on a thread somewhere. Now, this does work with several data formats. Parquet is a big one, CSV, and JSON. Unfortunately, it does not support optimized row columnar or ORC format, at least to my knowledge. I believe there's an issue open to support ORC, but so far doesn't support it. Nonetheless, given that Parquet is kind of the standard for data lakes in most places, that's not a big deal. Now, you can also install extensions that will allow DuckDB to read data from S3, from Azure Blob Storage, from Azure Data Lake Storage, GCP, etc., or Google Cloud Storage, etc. These are pretty powerful, and the extensions, if you're familiar with the way that Postgres handles extensions, it's a very similar feeling. We'll actually show off some extensions later on. And finally, because of the way that DuckDB stores its own data in its own DuckDB format, if you do save a table not as a Parquet file, but as a DuckDB formatted database, it actually stores that data in columnar fashion, similar to Parquet. What this means is you will get very fast analytical operations. You will get really good compression as well. So it's a win-win in that regard. And finally, there are a variety of interfaces that this product supports. You can install it from a command line interface and just run DuckDB commands from the CLI. You can install in Python, which is what we'll do. You can have R, .NET, Go, Node.js, Java, and a variety of other options. So you can install this and work with it in, I would say, probably about 90%, 95% of the programming languages that people regularly use. That's my weasel word for getting out of, well, does it support Cold Fusion? And the answer is, don't ask me. Unless you're using that weird variant of Cold Fusion that also uses .NET under the covers, in which case, maybe. So when would I use this? Well, I mentioned interactive data analysis, which is something data scientists do very frequently. I have a data set. I don't necessarily have it all prepped in a warehouse, and I just want to access this data. This is a very easy use case. I just want to write some SQL queries against a flat file or against some Parquet file or a few hundred Parquet files. But that's not the only use case. Data engineers can use this as, say, a pipeline component as part of automated data processing. If I have the CSVs or Parquet files or whatever coming in, I may need to ingest that data, reshape that data, and then write it out as a cleaned up data set. Or maybe I incorporate some lookup data, some other factual information to enrich the data. Well, I could do this in many different ways, and one of them is writing SQL queries. So if you're very familiar or comfortable writing SQL queries and you want to use that for most of your data transformation, this may be a good case for taking your files, performing the transformation, and then writing those files again. You can even use this as a database in a browser. It does support WebAssembly, or as a smartphone example. I mentioned SQLite as the relational database of choice for mobile platforms or for small form factor interaction. DuckDB is kind of similar in that regard. It is not going to be an expensive, resource-intensive product, so it can work in those cases. However, I have to set these expectations because DuckDB is not a replacement for an enterprise database system. I just spent a lot of time talking up, hey, here's how cool it is. Here are all the neat factors. Here are all the really nice parts of it. But it is not going to work for heavy transactional processing. You cannot have multiple people connect to it. There is no idea of role-based access controls or logins or users or any other kind of user-based security, and it has to run locally, cannot communicate over the network. So it's a local environment or within your container. So meaning, if I have a container that has maybe a Streamlit application and a container that has a fast API, well, if I want DuckDB, I can't have it in a third container that the two communicate with, which might be how you would initially think of staggering this. Instead, we're going to have the DuckDB process either in one or in both, and we do weird things with it. So it is a different story than what we would expect from a standard database product. Now, that said, let's talk about, let's say we're sold, at least we want to try it out, we want to see what kind of cool things we can do with this, so let's install. There are a variety of installers for DuckDB. Because this is an in-process database, there is no standalone installer. There's no MSI or executable or package that you install via apt-get or yum. Instead, it is a library in your programming language, with the exception of the CLI. Now, the CLI actually is an installer that is kind of standalone, but otherwise, if you want to interact with this using Python code, install it as a pip package. If you want it in R, it's a cran package. If you want it in Node, you have your Node packages npm, etc. .NET on here, that's a special case because the first 6 items on this list, these are all first party. DuckDB officially supports this, no question at all. Number 7, actually, it comes through duckdb.net, which is another open source project from people who do not work for DuckDB or the commercial company Mother Duck, and it offers your .NET support. So basically, this is a third-party installer for .NET. There's no real issue where DuckDB says, oh, we refuse to support .NET. It's just more of they realize they have a limited amount of time and expertise, and so for the rest of the projects, these are going to be community supported. Nonetheless, the installer does work. It does a pretty good job as well. So if you are a .NET developer and you're interested in DuckDB, it's pretty cool. But again, we're going to use Python for tonight. The installation process. There is a website where you can go to click a few things, and it'll give you a feeling for how you can install it. So in this case, I want the stable release from the command line for Linux. I just want to download things directly, and I'm running x86 or 64-bit architecture. In that case, the installation process, basically they're telling you, okay, well, use curl to download DuckDB from the install directory or the install URI, and then run the shell of your choice to install it. Not a big deal. If you click over to Python, it'll tell you pip install. If you go over to R, it'll say install.packages, etc., etc. So once you've got this thing downloaded, there's really no post-install configuration that's necessary in the general. So you're not going to create logins, you're not creating databases, and if you have configuration settings that you want to change, and we'll talk about a few of them tonight, but these are things that you can do in your code. So this is not something where you would have a DuckDB administrator who would be responsible for installing and configuring. This is entirely intended to be a developer-friendly database interface with all the pros and cons that come with that. Now, let's talk working with DuckDB. I'm showing you how to install it. We've got it. What do we do with this now? I can't go to the start menu and type in DuckDB and get my application. There's no DuckDB Management Studio or anything like that, sort of. But I will say, each client API does have its own idiosyncrasies. However, they are, for the most part, pretty similar. I will focus on Python code and the Python client in all of my demos, but probably about 85 to 90% of what we discuss, I could just as easily do in the CLI or in R or Go or Node or Java or .NET or whatever. The underlying application is handling most of this. There are some interactions in Python that are specific to Python, and I will call that out as we get there. But in general, this is going to work across all of the programming languages in pretty much the same way. So let's jump to my demo. And for my demo, I have here a notebook. So I need to make sure I am in the correct virtual environment. So that looks good. Also, need to make sure I'm getting more light over on this side. I don't like the way that lack of light is hitting my green screen, but we're going to have to deal with that tonight. Yeah, I'm not even going to try to change lighting. Normally I would do that, but instead I'm just going to complain about it. So let's talk about this notebook. This is going to be an introduction to DuckDB, and if you are interested in this code, I'll give you a link to the code at the end. No big deal at all. So let's talk setup steps. I do recommend that you use a virtual environment. I, in fact, have a virtual environment that I've created called .venv. Yes, please do link to the notebook. Not a problem. I'll give you that link for sure. This virtual environment, it's not mandatory, but it's something where if you are using Python, it's going to be something that you'll really want to dive into. You'll really want to create, because that way you can install DuckDB, you can try it out, you can mess with it, and if you really hate it, delete the virtual environment and pretend it never happened. Also, it'll prevent Python package version conflicts, which tend to happen a lot when you're working with a series of packages and nobody believes in backwards compatibility in the Python world. Now, all of the requirements, the required packages that we're going to need tonight are in this requirements.txt file. And I was admittedly kind of lazy in this and did not pin to specific versions of these various applications. So I am going to install Streamlit, DuckDB, Pandas, Polars, NumPy or NumPy, PyODBC, Matplotlib, and Plotly Express. I'm not actually using Streamlit, which means let's actually get rid of that. And I'm pretty sure I'm not using Plotly either. So I'll check this in afterwards, because that was a requirements text file that I took from another project that did use Streamlit. All right, all that said, I've installed the requirements already, so I have everything pre-installed on this machine. If you don't, you can run this pip command, pip install from a file, requirements.txt, and you can see that, hey, I already have everything installed, so hooray for me. I want to work with DuckDB. I also want to work with two other libraries called Pandas and Polars. So I'm importing the DuckDB namespace, and I'm also taking Pandas as PD, Polars as PL. Pandas is a library in Python that allows you to create data frames. Polars is a library in Python that allows you to create data frames. Polars is usually faster than Pandas, but doesn't have quite as much support for everything, and it can be a little bit of a learning experience if you focused mostly on Pandas before. We're going to use both of them because DuckDB actually supports both of them very well, and we'll see how. Now, there are two ways of communicating with your DuckDB database. You can either directly access via the DuckDB module, or you can open up a connection. If you're familiar with connections, ODBC connections, then you know that there's this multi-step process. You open up the connection, and then using that open connection, you will send one or more commands. When you are done sending all of your commands, you close the connection because you're polite that way. DuckDB's Python API does allow this, and actually we do generally prefer this approach, but you can also perform direct access. So, for example, this command right here, duckdb.sql, and then I select 42 as X and show the results, is for almost all intents and purposes the exact same as this command right here that opens up a connection and then selects 42 as X and shows the results and then closes the connection. You can see that the results are the same. It really didn't take any different amount of time. And so you might ask yourself, well, why does it matter? Why is it that I just recommended that you create the connection and close it? That's 3 times as many lines of code. That's ridiculous. That's heresy. But there are some reasons why we might want to do this. Reason the first, duckdb.sql is going to run commands against an in-memory database rather than a specific file. What that would mean is if I insert a bunch of data and then quit my application, that data is gone. It was in memory. It was never written out to disk. Now, if I create a connection, it may run commands against an in-memory database, or it could run commands against a database on disk. In this first example, I did not specify a database or a file that I opened. Therefore, it was still using in memory. So actually, these two commands are essentially the same. They are effectively the same. But I can specify a file, and then I would be working against that file, and I could save results. As I insert data into the table, it saves those results to disk, just like in real life. Now, DuckDB.SQL will also run against a shared global database. What that means is if I have two applications running on my computer at the same time, both of which are using DuckDB, and both of which are using DuckDB.SQL instead of opening a connection, they will write to the same database. That means that if those two applications happen to have a table called records or a table called customer, then you may have errors as I'm trying to insert, like I tried to create a table customers, but it already exists. My application crashed. Or I'm expecting my customer shape different because I need these columns and then the table has these other columns. It can be very confusing. And that's another big reason why, if you're using DuckDB in anger, if you're using it for real, make sure to create a connection right to your own database file. And that way you'll know there's not going to be another application, another running process of DuckDB that can interfere with your work. So in general, use the connections. There are specific circumstances, and I'll actually show you one of them tonight, where you probably want to use DuckDB.SQL, the SQL module. But this is not common. Okay, you can also use in Python this with syntax, and it actually matches very similar if you're familiar with C# and the way that you communicate via ADO.NET. In that case, it would be using instead of with. But in Python, with duckdb.connect, I'm going to connect at a folder DuckDB data, inside of which there will be a file.db. And if I look in here, I have DuckDB data, and then I have a file DB. I'm going to say, no, I don't. I no longer have that file. So what happens? Well, I'm going to open up this database. I'm going to say create or replace table test. And test is going to have just one column I. And we'll insert into test. By the way, a little bit of preview of neat functionality in DuckDB. Create or replace table. I would love to have that in T-SQL. So I run this. I have one record, 42. So cool. If I run it again, this is actually an idempotent command, meaning that no matter how many times I run it, I end up in the same state. So each time it will create or replace the table. If the table's already there, it's going to drop it and then recreate it. So I will only ever have one record in there with the number 42. Cool stuff. And it recreated the file, obviously. Okay, working with data. Now, the data set that I'm going to use tonight, this is the parking tickets from the city of Chicago. This is a database that Daniel Hoopmacher put together. I've got a link to it in the notebook. And he originally created from an open data set a bunch of flat file data from the city of Chicago. He turned that into a really cool SQL Server database. If you need a data set to play around with, this is actually a really well done one. I've used it for a number of series and videos and a number of presentations because I think it's particularly well put together. So I have thanked Daniel Hoopmacher literally hundreds of times, and I'm going to keep thanking him every time I use this thing because, well, it's what I do. But what I did was I extracted a lot of that data out into a Parquet file, and I'm going to use that Parquet file for the demo instead of a SQL Server database. This file is chicago.db, and I am going to delete this because I know where it's going. So chicago.db, we're going to create one. We're going to, in fact, I'm just going to delete this right now, and we're going to create it from scratch. And then I need to load data from a Parquet file. So I have this Parquet file, chicagoparkingtickets.parquet. And this is approximately 2 GB in size. So what I probably should do is vamp a little bit as I load this data. I am using pandas to read a Parquet file. Pandas isn't the fastest at reading Parquet, but it is really easy to do. It's a one-line method. So I'm going to read this Parquet file, and it's going to create a pandas data frame in memory on my computer. And then you might ask, well, how in the world would I get this pandas data frame into my DuckDB database, chicago.db? The answer is like this. I have a connection that I'm going to execute. Create table if not exists, Chicago parking tickets as select star from DF1. Note that I do not need to specify what DF1 is. It already knows that this is a pandas data frame called DF1. And that means it can interrogate the data frame, read the metadata, create the table using the metadata that this is a string, this is an integer, this is a decimal, this is a date, and then insert the data for me automatically. This is just native interaction with the pandas library. One of the huge advantages of working with the Python interface. The other interfaces, you're not going to have that same native interaction with libraries like pandas because, well, they don't have pandas. So we have our executed command. And if I show the results of this table of Chicago parking tickets, we can see that there are at least 9,999 rows. So many rows. And it shows us a quick sample, the different columns. We can see that this particular issue date is a varchar instead of a date. We could fix that. We could convert it. But for the most part, these data types look reasonable. Zip code being an integer, nah, it's not great. But okay, I could fix that. But I have my data set. This is in my chicago.db file. I'm no longer reading the pandas data frame, no longer worrying about that pandas data frame, no longer worrying about this Parquet file. So I'm working solely off of the chicago.db. My next command is going to be to describe Chicago parking tickets. And if I run that command, what we can see is all of the data types, whether they are nullable, if we have keys, if we have default constraints, and any other information that we have about the columns on this table. That does lead to the question of, well, can I create keys? The answer is yes. You can create primary keys, unique key constraints. You can create foreign key constraints, check constraints, default constraints. The normal set of constraints that you would expect from any sort of relational database will work here. Now, one difference, I suppose we're probably up to the third difference between SQL Server and DuckDB. Second difference, by the way, describe is kind of. But second difference, create table if not exists. There are several if not exist commands. Actually, this one, if I remember right, was added to SQL Server. It's alter table if not exists. No, alter table wouldn't work. Create table if not exists does not exist in SQL Server. It's drop. Drop if not exists does exist in SQL Server. I apologize for using exists so many times in the same sentence. That might get a little confusing. This particular syntax, not in T-SQL, is available in DuckDB. Wish it was in T-SQL. Would be really cool to have it. Describe, that exact command isn't available in T-SQL, but we do have system tables and dynamic management views that will give us the same information. So not too hard up about that one. But summarize. Summarize is a really neat bit of functionality because it is going to give us some quick descriptive statistics, where quick is relative. Took about 6 seconds here, which actually is faster than when I normally run this. Normally it takes me a few more seconds than that. So pretty happy about that. But I have for each column, the column type, minimum and maximum values, especially if this is a character. So for example, issue date is a varchar. It gives me the minimum issue date, the maximum issue date. We can see that this data set runs from January of 1996 through May of 2018. That was the latest date. We have approximate number of unique values. So here, 52.7 million unique values for ticket number. Approximately. Hold that note. Hold that thought in mind. Now, for numeric values, for columns that are numeric instead of string, we also get the mean and standard deviation as well as a 5-number summary. We already had the minimum and maximum. We also get the first quartile, the median, and the third quartile. So we get that 5-number summary plus mean and standard deviation for each column. Finally, we get the actual count, the actual number of records. So there are 49.9 million records. And then you might say, but wait, it says there are 52.7 million unique values. Not so great at estimating. I believe that this does not use hyperlog log, so it can be a little bit off. This is a few percentage points off. It's almost my calculations there said it's almost 5 percentage points off, which is higher than the threshold for what you would expect from hyperlog log. If you're not familiar with that algorithm, hyperlog log is a really nice algorithm that allows you to approximate the distinct number of values in a set. And it's accurate, if I remember right, to within about 1.6%, 95% of the time, something like that. SQL Server uses hyperlog log for count distinct, or excuse me, for approximate count distinct. It uses an exact calculation for count distinct. And that's why approximate count distinct can be orders of magnitude faster than real count distinct, because we don't need to scan the full data set. We only look at a sample of the data and then get our approximation. This is also using a sample of the data and giving an approximation, but maybe not quite as good. Still, you can see just from this description, this high-level summarization of our data, a lot of information. We can see that there are relatively few values for most of these columns. This one, obviously, this is a unique identifier. And ticket number, it's a unique identifier. It just it kind of has to be given how many approximate unique values there are. The rest of these mostly look like they're lookup data. Some of them, payment is outstanding. We have 2 possible values for it. So very clearly, either a label or a lookup value. And so we can intuit a lot of information just by looking at the summary. Now, that took 6 seconds, and maybe I don't have 6 seconds to wait. So I want to write this out to a table. So I'm going to create or replace a table, Chicago parking ticket summary, as selecting star from summarize. So this summarize creates a result set that I can then select from and insert the results into a table. And then I can query that CPT summary. Now, I can write pretty much anything that's in ANSI SQL. This product does pattern itself mostly after Postgres. So in general, if it's part of what several companies offer with ANSI SQL, you're probably going to find it here. It may not be exactly the same as what we have in PSQL or T-SQL or Oracle's PLSQL, but you're going to find an analog. So obviously select count star, 50 million records. And by the way, that's pretty fast to come back with 50 million records. Select my summary, so I can query my summary table very efficiently. Let's talk a bit about syntax. This is an example of a query that uses a case expression as well as aggregate functions. And this query is pretty much exactly the way that I would write this in T-SQL. So we have from Chicago parking tickets, we're going to select our police district. We're going to say if the license plate state is Illinois, we'll call this an in-state ticket. Otherwise, we'll call it an out-of-state ticket. And then we'll get the sum of payment is outstanding. I will tell you payment is outstanding is a 1 or a 0, and that represents whether or not somebody still owes money to the city of Chicago for that parking ticket. If it is a 1, they owe money. If it is a 0, either they paid the money or the ticket got thrown out in court, or the city basically wrote it off as we're never going to get it. Well, we have non-aggregated columns. We have an aggregation function, so we need a group by clause that includes those non-aggregated columns. And then I would like to order. I would like to order by my sum of payment is outstanding descending. So I run this, and the only difference, T-SQL, I would say order by ticket is outstanding descending. But you know what? Oops. I run this and it's the same results. No big deal. So we have our police district, we have in-state and out-of-state, and we have the number of tickets that are currently showing that people owe money. So for police district 1 in-state, we have about 1,000,000 tickets and on and on. Next thing that I want to talk about is pivoting, because DuckDB does support the ANSI SQL pivot keyword. But if I were to poll the audience here, I would estimate that nearly 100% of us could not write a pivot statement. If you held a gun to my head and said, write the pivot statement or you get it, I don't know that I would write a correct pivot statement. And I have written many pivot statements in my life. It's just syntax that seems like it just slips out of my brain. Now, I would go to Microsoft Learn and go check out what the syntax is and say, oh, yeah, that's how you write it. But especially for a slightly more complicated pivot, not going to be trivial. So let's see how DuckDB handles it. We have here select police district and license plate state and tickets outstanding, etc. This is our same query as before. But now I'd like to pivot my records. So pivot my common table expression records, which, by the way, common table expressions, no problem, full support. We're going to pivot records on license plate state using sum of tickets outstanding, and we're going to order it by police district. So this is a fairly standard pivot operation. Pivot table on column that we're going to pivot using aggregate that will populate the pivot table, order by non-pivoted column. That's not too bad. This is probably like the easiest pivot function that exists. Anything beyond that, you start getting into worlds of complication. But I can also pivot a subset of my data. See, I can say pivot records on police district in 1, 2, 3, and 4 using the sum of tickets outstanding. And in that case, you'll notice that I've kind of flipped this. Instead of pivoting on the license plate state, I'm pivoting on the police district, and I'm making that into my columns. And then I have the license plate state as my rows in this pivoted matrix. So that's pretty cool. Allows me to easily specify, here's my set. But that's also standard SQL. You can write that in T-SQL as well. Where things get a little bit more interesting is that I can also pivot records on a police district using my sum is outstanding order by license plate state. I mean, that's again fairly easy. I just changed this. Instead of saying in state versus out of state, I'm showing all the individual states. And as we all know, there are 71 states in the US, including Alberta, British Columbia, and DC. Puerto Rico's in there. The Virgin Islands is in there. Guam is in there. Even Alaska's in there. Even Missouri. I don't believe in Missouri as a state, but it's in there. So we can see, if in case you're curious, all 71 states, including the state of Null, which has nothing in here, but it's still there. All right. We run into a problem very frequently with a pivot, where I told you there is an aggregate function, but I want 2 aggregate functions in my pivot. And the answer is no, too bad. But in DuckDB, the answer is, okay, just separate it with a comma. So I can say sum of payment is outstanding and then max of officer ID and run this thing. And what I get is, for my 4 police districts, I have District 1, sum, payment is outstanding. District 1, max, officer ID. So I can see for each state how many there are in that associated with that police district, how many tickets are still outstanding, and what is the highest officer ID associated with a ticket tied to that state. And it repeats for all 4 of these. So that's pretty nice because the columns are ugly. I'll readily admit that. Column names are kind of ugly there. But that was a really easy way to get a multi-column, multi-aggregate pivot table, which is hard to do in SQL. It is much easier to do that in Excel in a pivot table, but really hard to do in SQL using the any relational database product. So it's definitely an advantage of DuckDB here. Now, I can also unpivot. Like pivot, you can follow the ANSI syntax if you so desire, but DuckDB does have a simplified version of the syntax. And this that I showed for pivot was the simplified version of pivot. Here is unpivoting. I'm going to have to show you a weird example. Please bear with me for this weird example. We have a common table expression records. Police district, license plate state, payment is outstanding. That part's, we've seen it before. We have our pivoted data. We're pivoting records on police district 1 through 4 using the sum of payments is outstanding. But then, after I pivot this, I spend all of my time pivoting this. Somebody comes to me and says, but I'd really like to unpivot it. And you might say, but why didn't you just leave it unpivoted to begin with? The answer is because I needed an example, okay? I only have the one table, so we got to do what we got to do. We are going to unpivot the pivoted data set on columns. So this is actually some DuckDB magic. Star everything except license plate state. So we are going to say everything except for license plate state, we're going to unpivot. And we're going to put this, now it turns out that there are 3 things. There's police district, there's license plate state, there's payment is outstanding. Well, the name will be police district, the value will be payment is outstanding, and we're going to order this by police district. So why I did this is I have in here license plate state that was not part of the pivot. That was the column that remained not pivoted. So I'm going to unpivot every other column. If I go back up and look here, the other columns that I have would be 1.0, 2.0, 3.0, 4.0. So we're going to leave license plate state. We're going to unpivot the rest of the columns. And as I do that, what I'll end up with is license plate state, police district, and payment is outstanding. So we have the 3 columns. We have these 2 features and a count of number of outstanding payments given this license plate state and this police district. So unpivoting works very clearly, very cleverly. All right. One thing that if you are a heavy user of SQL Server or most other relational database platforms is you're familiar that you can alias columns in the select clause, but you really can't use those aliases anywhere other than select and order by. And the reason for this is the way that a relational database engine processes. It parses the SQL query. And so that order roughly starts with the from clause. Then we have our join clauses. Then we have our where clause. We have our group by and having. Then we have a select. And then we have an order by. And so if you do something in the select, it can't affect things that are higher up in the processing order. That's a big reason why I can alias a table in the from clause or in a join and then specify that in my where clause, but I cannot alias a column in my select clause and use it in my where clause, unless I'm in DuckDB. Because in DuckDB, I can say from Chicago parking tickets, give me police district as PD, give me this license plate state as license plate state, and give me payment sum of payment is outstanding as tickets outstanding, and then where PD in 1, 2, 3, and 4. So I don't have to specify police district. I don't have to specify this full case statement. I can say where license plate state in TN, etc. And then I have a group by, I can group it by PD. So again, I don't have to group by police district. I just group by the alias. And you might say, well, what about this license plate state? Well, I actually renamed this alias. So let's pick it a different name, state name. And then let's try this. I'm just going wild. I'm just going to say, show me state name. And hey, it worked. So I can group by state name. And I can also say, and yeah, in state, out of state, whatever. So I can specify those aliases instead of having this long, relatively speaking, long case expression. I can just say, give me the alias and query it. If I wanted to do this in SQL Server, I would put the initial query in a common table expression, then I would select from the common table expression using those aliases. So we have a way around it, but it does add a little bit of extra mental processing time to the load, just to get things in the right format, and then we write the query the way we want. There's also a columns function. Now, this columns function lets us pass in lambda expressions. A lambda expression is, think of it as a way of saying, iterating over a collection, I want to execute an anonymous function for each element in that collection. So for columns, for each column, which I'll call COL, I would like to get the columns whose name starts with PER and then goes on. So I can say select police district and then all of the columns that start with per. And I'll limit this to 10 rows. So instead of T-SQL's top 10, we have the more PSQL or PLSQL, or like MySQL uses limit 10. So basically, we use a limit clause. But otherwise, columns, really cool, because that let me say per capita income, percent unemployed, percent without diploma, percent households below poverty, without specifying all of those names. Here's the downside. You cannot use this in a group by clause. So if I have an aggregate function, I actually have to specify all of the columns. However, this could be something that you could use to maybe insert into a table and then select from that table with your group by clause, or do something else. It does, at the very least, reduce the amount of typing you have to do if you have a very wide table and you want to get a common subset. You can use other patterns, not just this style. But yeah, that's the general idea. I can specify column names. Now, there is a very common debate in the SQL writing world about, should you have commas at the end or at the beginning of a statement? So here, a column. So should we have comma sector, commas, whatever, or should I put commas at the end? And the argument that the comma firsters use, and you may notice I am definitely not a comma firster. I believe in commas where they belong, at the end. But comma firsters will say, yeah, but then I can comment out. I could comment out this one, and then my query won't break. Well, DuckDB's got you covered, comma enders, people who know where a comma belongs, because I can actually have a comma at the very end, and it'll work just fine. So I can leave all of my commas exactly where they belong, and I can end with a comma after before the from clause or whatever, and everybody's happy. Also, you may be familiar with the way that T-SQL or other SQL variants will nest functions. So I have sector, and I want to uppercase sector. And then I want to replace spaces in sector with underscores. And then I want to trim that. I want to left trim and right trim. This style works, but it can get very confusing because you kind of have to go into the middle and then read it out. So sort of a reverse Polish notation for function operations. DuckDB allows us to chain functions. So we can say sector.upper, uppercase this, replace spaces with underscores, and then perform a trim. This syntax will work. This syntax is clearer for humans. And the function chaining is just dots. No big deal. So those two bits of functionality, again, very helpful. A good way of allowing you to perform some regular data transformations and make it easy to understand what's happening in your SQL pipeline. All right, next up, let's talk joining. So far, I've only had one table, but in reality, our databases usually have like 5 or 6 tables. So we've got more than one table. Some of us, I've heard, may even have a full dozen tables in a database. Now, those people, they're living large, but we're going to try to replicate that a little bit. We're going to create a new table, license plate state, and that would be the state abbreviation and a region. And this is enrichment. This is data enrichment here. Because I'm going to insert into license plate state, we're going to pick your state. And then if your state is Illinois, then you are in state. If your state is Indiana, Wisconsin, Michigan, Missouri, even though I still don't believe it's a state, Iowa, Kentucky, you are a neighbor of Illinois. If you are in Alberta, BC, or one of these others, basically you're out of the country. And so don't care. You're just somewhere else. Otherwise, you are in country but not a neighbor. So we're essentially breaking this out into 4 regions, 4 concentric circles growing as we expand beyond Illinois. I will also create another table, community details. And community details are they are columns that tie in with the community name. One of the things that Daniel put together was some general level details on basically things like per capita income, unemployment rates, diploma or household below poverty rates for different communities in Chicago, with the idea being that you might be able to analyze the tickets and then these demographics about the different communities and see if you can find anything interesting. So I've got these tables, and DuckDB will support all of your classic ANSI SQL joins. So you get your inner join, your left outer join, your right outer join, your full outer join, even cross join. So we get all of these. Here's a quick inner join. So Chicago parking tickets, inner join license plate state. It looks exactly the same as we would write in T-SQL. So this query, just the same. And I'm also showing the maximum number of rows, 100. So give me up to 100 rows. All right, so that was a simple join. No big deal. But I'm going to pivot just a little bit and talk about another fun feature, and then we'll come back to that. One of the complaints that you will have about SQL from a language design standpoint that you'll hear from language snobs. Admittedly, I consider myself a language snob as well, but SQL really needs to start with a from. From is the driver. And in fact, if you use, let's say you use something like SQL Prompt, or that you use IntelliSense in Management Studio, more often than not, you're probably writing the from clause first, or you're saying select star from dbo.mytable so that you can go up, replace the star with the columns that you actually want and get the IntelliSense help. If you start the query, if you write the query literally as is, you write this thing select, I need a region. Okay, so I need region, but LPS, license plate state. Well, I don't know about license plate state until I read further down in this query. And then I have to come back up. Okay, account star, that makes sense. I don't really need to read further. But CPT, what is CPT? Oh, Chicago parking tickets. If you look at how we would parse a query mentally, we start here and then move up to the select clause. Or we bounce between the select clause and the from and joins to help understand the context of the select clause. Basically, the select clause is in the wrong location. It should actually be further down. Now, you can have a from clause without a select in DuckDB. It is the equivalent of a select star. So from license plate state ordered by abbreviation, select star, implicit. Or you can also say from Chicago parking tickets inner join license plate state, select lps.region. Oh, I already know what that is because I already read this line of code. So now the select clause references what's up here. The where clause, the group by clause, the order by, having would fit in between here. So all of these things have to be in the correct order. You can't just put select anywhere you want. It is either before the from clause or after from and any joins. But this is another perfectly cromulent query. And it will return exactly the same results. It will behave exactly the same way as if you had the select clause in the normal location. But for the language snob, it's actually kind of fun. It's kind of nice to be able to do this and to write the query in a way that makes more sense. And that, frankly, as you write more queries, you probably are writing this in kind of this order already. You're just having to move your cursor back up to the top in order to write the select clause, and then you come back down to write the where clause. And I just wanted to show you here Again, if you look at the numbers, if you look at the results, they are literally the same. Even if you looked at the execution plans, they're the same. Now, one thing, T-SQL superpower. A T-SQL superpower is the apply operator. The apply operator exists in ANSI SQL as the lateral operator, and DuckDB supports lateral. Now, why is it apply in SQL Server? The reason is Microsoft came out with this while the ANSI SQL committee was still arguing about the concept, and then they said, "Oh, well, we're going to call it lateral instead of apply." And Microsoft basically said, "All right, well, we've got apply already. We're not going to change the name just because you changed the name after we released the product. Deal with it." And thus, we have dealt with it. And it's fine. I like apply a lot. Lateral behaves the same as apply. For each element on the left-hand side, we are going to execute a function or expression on the right-hand side. So in this case, select star from range of 5, lateral, select I plus 1. So let's talk about this. Range. Range is a generator. Range will allow me to generate, this is from 0 through 4 inclusive because it uses Python style numbering. So I'm creating a table. I'm generating a table with one column called I. I'm aliasing this thing as T. And then I am performing a function for each element in this generated result. Select that plus 1, and we're going to call that column J. So if I run this, we see 0, 1, 2, 3, 1, 2, 4, 5, 3, 4. And you might say, but wait, Kevin, why is this not in order? And the answer is because it's SQL. In SQL, if you do not specify an order by, you will get whatever order the database engine gives you, and you will like it. Otherwise, give it an order by. Provide order to life. Let's say that we want to provide order to life. Well, there are, obviously I can write an order by clause. It's easy enough. I can order by I comma j or t.i comma t2.j, depending on whether or not I want it to be polite to future me. Now, the result of my lateral operation can be 0 or more records. In this case, I generated 1 record per starting point. I just added 1 to it. But let's say that I want to generate series. So generate series, we're familiar with that in T-SQL. That was added in SQL Server 2012. And so we've got this generate series, 0 to 2. We're going to say, well, that'll be a table called T. It'll have a column called I. Then we will perform a lateral operation again. This time we will select I plus 10. We'll select I plus 10, but we'll also select another row, I plus 100. So we're going to have 2 rows per input record. And I'm going to order by all because I am far too lazy to say t.i comma t2.j. Instead, I will just type all, and it will order by columns in the order in which they appear in the result set. So we'll order by I, then by j. So it's pretty helpful that way. Now, we have this notion. At the end, beginning is just crazy talk. Yeah, I agree when it comes to commas. So absolutely, 100%. Positional joins. Positional joins are kind of weird from the perspective of set theory operations, because when we think about a set and we think about a join, what we're doing is we are attempting to perform a match. We're trying to find what are the elements of a set that match. This steps on the face of set theory. I don't like that so much, but this is something that is incredibly common in development, where I have a list here, and I want to have the first element of this list and the first element of this list. I've got them already ordered the way I need to, and I just need to pair these things off. In the functional programming world, that's called the zip function, where I zip the first element and the first element together to create a new thing. The second and the second create a new thing. Third and third, etc. Let's do that here. We're going to create 2 tables, T1 and T2. So we've got X and S. So for T1, I'm going to insert 1, 2, and 3. For T2, I will have A and B. Notice I do not have 3 rows. So we are going to positional join T1 and T2 such that the first record in table T1 will match with the first record in table T2, the second and the second, the third and Well, let's find out what happens with the third. So I run this, and we have our match, and then we have null. So anytime when we don't have a match between those, if we have a mismatch in numbers, we're just going to have a nulls. All right. So next, we can include tables in lateral operations. So it's not just expressions. This is, in other words, this is just like the apply operator. Here I have range. So I'm building up 5 records. And then my lateral is I'm going to select S from records. So here I'm taking T1 positional join T2. And where T.I is equal to records.x, I'm going to get the top value ordered by S descending. It's a little bit weird. It's a little weird of a query. But what this does is it allows me to perform another lookup. I can perform for each record in this set a function call. And you'll notice that it is only returning back the records where there is a match. I forget if there's a left lateral. No, there is no left lateral. I don't remember off the top of my head what the equivalent of outer apply is for a lateral. It's not outer lateral either. So I probably should have looked that up beforehand before just winging it. But anyhow, this is the equivalent of a cross apply. So it's kind of the equivalent of, it's the semantic similar inner join, which is why we're only getting 3 records back. But there is an equivalent for this in ANSI SQL that will allow you to do what we do with outer apply in T-SQL. Earlier, put a link to the notebook and meetup. Yes, I can absolutely do that, Elaine. No worries. So support for polars. I mentioned pandas. I mentioned polars. Polars is kind of a faster, usually a faster interface. So I'm going to create a polars data frame. This data frame will have a few columns and it'll have some lists of elements. And we have a data frame. So we have A, we have a fruit, we have B, we have a car. And so for each one of these rows, what I'd love to do is basically convert this thing into a DuckDB table. Well, let's select all of these. Oh, whoops, sorry, I've already done it. Basically, I said select star from DF and show it, and that's what we showed here. So we have our data frame, and I just selected from it. No big deal. It just exists. Now I can also take a SQL result set and write it out as a polars data frame using that .pl function. So if I do that, I can create a data frame. Here I've got IDs and fruits, 1 in banana, 2 in apple, 3 in mango, and I turn that into a polars data frame. You might say, can you do that for pandas? Not that way, no. So this is a bit of polars specific functionality, but it does allow us to specify that this is a polars data frame. All right, before we wrap things up, I will talk about explain plans. Here's my wacky pivot then unpivot. I can call the explain method on this SQL command. And what it'll do is it will generate this variant, this visual execution plan. So we'll get an idea of cardinality. We'll get an idea of the operations, the individual operations that are happening along the way. And you'll get a chance to understand what the relevant performance problems might be. Reading one of these, I don't think this is as easy to read as a SQL Server graphical execution plan, but it does provide us a lot of the information that we would want to get if we were performance tuning. So the way to do that, just add a .explain and it'll write it out. This, because I'm in Jupyter, it knows that and thus writes it out in a very pretty format. Otherwise, you can write it out as a text in a text format, sort of like the tables, the style of tables that we've seen so far. So it works out okay. All right, I do need to call out data deletion. Data management, data deletion, because in DuckDB, this is different from major database systems. So let me create a new table called Chicago parking tickets _ delete me as select star from my Parquet file. So this is going to take a few more seconds. So what I want to do is I want to do this over on this other screen so that you can't see all of my drives. And then I'm going to go into getting started with DuckDB. We're going to go into DuckDB data. Boom. Real quick, Chicago.db, 1.5 gigabytes. 1573 just jumped up to 3161. Basically, we doubled the amount of space that we are using for our data. So I just wanted to point that out. So let's drop that table. We say, whoops, I didn't mean to recreate that table with 40 something million rows, almost 50 million rows. Don't worry, I'll drop that table. Now you may have noticed if you were quick of the eye, that it created this new file, .wal, write ahead log, and unable to read that file. That's okay. Can't read the file is probably because the file is open. It's currently in progress. It is a 1 kilobyte file that basically acts as the transaction log. So it's telling DuckDB, we have a transaction that we have not committed. So we've performed that delete operation, but it hasn't actually committed yet. So that might explain why, if I look back, this is still 3.1 gigabytes. So, okay, well, let's vacuum. Let's vacuum that, because this is what happens in Postgres. If I clean up deleted tuples, I just vacuum. It's how I delete deleted tuples in Spark is vacuum. And if I vacuum, nope, it's still here. It's still 3.1 gigs. It's the same as before. So, scratch your head, wonder what the heck is going on. It turns out that vacuum actually does nothing in DuckDB. It was added basically so that Postgres people could vacuum. It does literally nothing. It's a no-op. But what we can do is execute a checkpoint. So let's run checkpoint. And if I run checkpoint, the write ahead log went away. So clearly we're back down to 1.5 gigs. No, we are still at 3.1 gigs. We still have all of the data. Now, okay, if file size is not a big concern, if you're not deleting a bunch of records, no big deal. But if it is a concern, we can make a copy of the file to a new file. And what that will do is it will ignore the deleted tuples and will only move the active data. This is, in my opinion, kind of hokey. But if you do need to clear out those deleted tuples, this is the only way that we can do it. So I'm going to create a Chicago2.db. It is now an empty file. So if I switch over to File Explorer, we can see Chicago2 is 12 kilobytes in size. Then I'm going to close my original connection. Okay, great. Finally, in the global module, I will connect Chicago and Chicago2. I'll call those Chicago as DB1, Chicago2 as DB2. And I will copy the active contents of DB1 into DB2. So let's do that now. The attach command will let me attach a file as a database. And then I can copy from database DB1 to DB2. It took about 5.5 seconds. And if I check out DB2, DB2 is 1.57 gigs. Incidentally, my original Parquet file is almost 2.2 gigabytes. So actually the DuckDB format for columnar style storage is more efficient than my Parquet file. So that is a pretty interesting thing to know. Now, to wrap up this notebook, let's talk extensions. Because like Postgres, DuckDB builds extensions. The development team builds extensions, the community builds extensions, and that adds value to the product. If I look at DuckDB extensions, this is a function that will show you all of the different extensions that are available for us, as well as whether or not we have it installed. If you want to install an extension, it's actually really easy to do. Install spatial, load spatial. So that's how I install an extension and then make it available. And then I can check all of my installed extensions and see that I do have spatial. I have Parquet, so I can actually read a Parquet file or write a Parquet file. I can work with JSON. And there's even a TPCH. TPCH is the standard for generating a sample artificial data warehouse data that uh, relational database companies use to test their products. So that way you can say, oh, well, on TCP or TPC-H, we performed this well on these queries. We were 28% faster than Oracle or whatever. Nonetheless, the one that I cared about here is spatial. So I can make use of spatial queries. So I can create polygons. I can uh, generate JSON shapes. I can calculate distances. No big deal. One other thing I want to talk about here. Like any data platform technology, or frankly, any programming language that will allow you to execute arbitrary code, DuckDB is susceptible to SQL injection. So if you write injectable code, you can get injected. I mean, this seems obvious, but I needed to make it clear. So in this example, I have two functions. I have a variant of a function that is susceptible to SQL injection. So let's see what it does. We are going to open up my Chicago database, and then I will run a formatted string and fetch the results. So I'm selecting X, which is my input parameter, as X, and I'm running a fetch all. And then I close the connection, I return the result. I will say, functionally, this code does exactly what you expect it to do. However, this X is a non-sanitized parameter that allows for arbitrary insertion of whatever, and we're going to make use of that. By contrast, this is parameterizing a query using DuckDB. So we can execute select question mark as X, and then I have a tuple with all of my input parameters. So each question mark, based on its order in the query, shows up in here. Let's see how these compare, how these work. If I run this with reasonable data, file is already open. Doggone it. All right, well, fine. I'm going to open up something totally different. Let's call it, let's just use file. It doesn't actually matter which one we're using. There we go. All right, return back 42. So 42 is our result. And then here, 42 is our result. Hey, query works fine. Push it to prod. No big deal. But if I run an injectable query and I then say, let's put a semicolon and then basically the equivalent of select star from DuckDB settings, and then have this comment to comment out whatever is at the end of the query that we're intercepting, I now have all of your DuckDB settings. So not cool. But with the parameterized query, I cannot escape out of the parameter, which means that I just literally get back the attempted SQL injection attack as my parameter. So this is the correct way to operate data input in DuckDB. It's the same way as you would with SQL Server. Quite frankly, you parameterize your queries. So there's nothing special about it, but I did want to call that out because knowing that this is going to be developer centric, well, we have to remind developers that SQL injection is a real thing. Okay, let us briefly talk administration and limitations. There are a variety of set statements that allow you to change configurations, memory limits, sort order, descending or ascending, collation if you want to have case sensitivity for some mad reason. Set commands set the value. Reset commands return to the default. And you have global and session level values. So global is the entire DuckDB instance. Session is just my current session. DuckDB does have over 100 separate settings. You can get them all at DuckDB_settings as a function. Pragma commands are very similar. They follow a similar format to what we do in SQLite. And they are kind of the equivalent of system tables or DMVs in SQL Server. So there's a pragma to list your databases, to show your tables, to list table information given a name, a specific table name, database size, how you're storing the data, blah, blah, blah. These things are they're easy ways of getting metadata about your tables and your databases. You can store DuckDB secrets. These are the different types of secrets that you can include. So you can get Azure, Google, S3, MySQL, Postgres, Cloudflare, R2, Hugging Face, etc. These secrets generally come as you install extensions. So you can use the create secret command and you can store those details. Here I've got an Azure, simple Azure connection string. So I could save the connection string itself as a secret. I could save the type is Azure, the provider is a whatever credentials that I have set up already. The chain will be go check my CLI or my environment variable. So this would be where I have some credentials already set up in a credentials file. Go find it. And then here's the storage account name. Or if I have an SPN, a service provider name, or excuse me, a service principal name, then I can say this is a service principal. Here's my tenant. Here's my client secret. And then here's the account name. So we have for each extension, they have specific ways that you can collect secrets. As a warning, 2 warnings. I'm going to give you 2 warnings on secrets. Number 1, secrets do not persist between sessions unless you use create persistent secret. Number 2, if you do create a persistent secret, notice right above my head, this saves secrets in a folder called .duckdb, stored secrets. Now you can set the secret directory somewhere else, but this is unencrypted binary data, and it has permissions that in Linux speak are 600. User can read and write. Nobody else can read, write, or execute. This is basically the same as what we would do for an SSH key. So it's not quite as bad as it sounds, but do note that you are saving your secrets that are technically unencrypted. It's just that only your user account is allowed to access them. Now, if you have a persistent secret, then you can drop them, drop persistent secret, and it will delete them from the file. Finally, a couple of limitations. DuckDB, no logins, no passwords, only one user. And there's really no other way of preventing access to data. So it makes things really simple. We don't have to worry about role-based access controls or creating roles and understanding how permission chains work, et cetera, et cetera. But we still have some ideas of how to keep data safe. So for example, if you're using the CLI, you can run this in safe mode. This will prevent DuckDB from accessing any sort of external files other than your database file that you've selected at the beginning. That way, someone can't basically use a directory traversal attack to go up a couple of directory levels and get the contents of files. So here we can specify and say, no, you get the one file I tell you that you're allowed to get. You can restrict access to specific file systems or even all external files. So you can disable file system access. Or you can say, I will allow you to read files in these specific directories. And if you also set enable external access to false, that limits you to just those directories. So I might have my Parquet files that are in a data lake, and I don't want you to escape the data lake and read anywhere else. I can set those allowed directories. A couple of security tips. We do want to set memory limits, maximum number of threads, and temp directory size. This way you can prevent an out-of-memory attack or a CPU throttling attack. So I can set the max number of threads. 1 may not be the correct number. Maybe memory limit, we might set it to 5 gigs, 4 gigs, 12 gigs. Basically, a number that is small enough that it's not going to overwhelm our computer, whatever computer we're running this on. Maximum threads, number of CPU cores or fewer. Max temp directory size, limit the size of temp files and prevent running out of disk space. So do all 3 of those things and you'll prevent denial of service attacks via DuckDB. Now do be careful in whatever extensions you install because anybody can create an extension and you might have a supply chain attack from an extension update. So you can limit yourself to just core extensions. Set allow community extensions equals false. If you run this command, you cannot turn those back on without restarting DuckDB. So that means maybe as a startup command. So you have your application startup and it runs a script that includes a set for allow community extensions equals false. That way, if a malicious developer or if a malicious end user tries to force install an application via some SQL injection attack that you haven't fixed, they're not going to be able to do that. Speaking of SQL injection, we already saw the demo. So use prepared statements to prevent SQL injection. You can see the example here where x equals and then string 42. That's not going to be a good way of doing things where you're concatenating strings together. Instead, use prepared statements with explicit parameters and you will be good. Finally, something to keep in mind is that persistence is optional. DuckDB can be entirely in memory, or it could be a permanent store of analytical data, or frankly, you can use it both ways. And you can natively read a variety of file formats. We said Parquet, CSV, JSON. That's a huge percentage of data sets that are out there in the world. Plus, if you have the extensions for blob storage or S3, well, I don't even need to migrate that data down to a local machine in order to use it. I can just access it directly from Azure Blob Storage, from Amazon S3, or even from Google Cloud Storage if I have that extension. But if I do just want to pack up my work for the night, save it, I can save the results to disk. So I can save it to a DuckDB database file, or if we're using Python, remember that I can convert in and out of pandas data frames and polars data frames. So even if I'm using DuckDB just for in-memory purposes, I can write that out to a pandas or polars data frame and then write that to disk as a Parquet file or JSON file or whatever I have. Constraints, they're a little weird. DuckDB does support constraints. I mentioned foreign keys, primary keys, unique keys, check constraints, default constraints. But there are some strange ways that they've implemented operations. Like updates sometimes are actually a delete followed by an insert. And well, if you have a foreign key constraint and you try to update the parent record, it will delete the parent record and then insert the new parent record, except that it'll fail to delete the parent record because there are child records associated with that parent record. So this can be a problem. Foreign key constraints do exist. They may not be as helpful as you'd hope. Now, that what I just said might change in the future. They may actually fix that. I consider that a bug. I don't think they consider it a bug. I think they consider it as, yeah, it's how it functionality should work this way, but we'll get to it one of these days. Until they get to it, though, I may not recommend foreign key constraints. You may also have similar issues with unique key constraints and updated commands, so just keep that in mind. Over the course of this talk, we've done a basic introduction to DuckDB. We've looked at some of the client APIs. We've spent a lot of time in Python. I showed you the SQL syntax. We talked about how to manage databases. We looked at some product limitations and even how to manage those DuckDB installations. If you want to learn more, if you'd like to grab these slides, if you want to grab the demos, if you want links to additional resources, all of that is at csmore.info/on/duckdb. If you have any questions afterwards, please do feel free to send me an email or hit me up on X or whatever. Details are right there. And with that, I will be available for questions. If you have any questions, get it in chat right now. Otherwise, I do want to say thank you so much, and I hope you enjoyed it. So I'll hang around for just a moment for additional questions if we've got anything. In the meantime, since I am also the MC, the master of coordinations here, or ceremonies, master of ceremonies, I need to vamp. Oh, I don't have to vamp yet. Thank you for the presentation. Interesting to see the technology there. Yeah, there's some really cool stuff that they have done with the product. And again, it's not a replacement for SQL Server or Postgres or mainline database. But for someone who is on a laptop just futzing about, it is so much easier than saying, well, you can install SQL Server Express Edition or Developer Edition, and then you're going to have to learn how to get that data into here, and then you're going to have to work with it and deal with all the security permissions and blah, blah, blah. So it is absolutely a much lower level of difficulty getting in. Are there ways to see what is in memory so I can drop objects when I start to hit memory limits? Ooh, that's a good question. My recollection is that the entire file, if you're working off of a database file, everything's in memory. So you're not going to be able to have like a 200 gigabyte data file, is my recollection of things. I would have to go back to double check, but I believe that is the case. It's not, again, it's not like a SQL Server or a Postgres where we have our data written to disk and then we're paging in and out of memory. Um, it is instead more of a memory first database. Looks like people had some aspects they were annoyed with in T-SQL or in PSQL, and implemented some things to smooth out the rough edges. Absolutely. I think you do see a lot of that, and basically, it's kind of a similar story to Postgres and Oracle, where a lot of Postgres developers, especially the early folks, were Oracle people, and essentially said, "I want to fix some of the stuff that I don't like about Oracle. I want to do this thing. I want to write this slightly differently. I want to support other languages and etc. I want extensions. I want additional capabilities or to move faster on implementing ANSI SQL standards." And so that kind of became the ethos of that product. And you see something a similar feeling with DuckDB of, yeah, I want to make life easier for a data scientist. If I'm just going to write a select star statement, why are you making me write select star? Just say from. Or if I am going to use a product that will allow for some level of auto completion, and there are a couple of clients that are specialized for DuckDB, one of which, if I remember, comes out from Mother Duck, and I think it has IntelliSense, where if you start with a from clause, it will actually follow along and help you write your select statement. So that does make life a little easier in many respects. But all right, we've been going for almost an hour and a half. I appreciate everybody who came out tonight. Hopefully, you enjoyed the session. Quick reminder: SQL Saturday Raleigh, May 17th. So go check that out, SQLSaturday.com. And that's going to do it for us for this month. Next month, we've got a whole new slew of presentations. So check all that out at meetup.com/trypass. And until we do see each other at a future meeting or an episode of Shop Talk, or because I'm riding your tail on the freeway or something. Hopefully that wasn't me. I definitely wasn't doing that. I only drive the speed limit. So nonetheless, until we do see each other sometime later, everybody take care.